Here we are talking about the oblique elastic collision. Elastic collision in two dimension. So see how we are going to find the equation for elastic collision in two dimension. See here, one mass m1 u1, initial velocity u1, it is an angle theta 1, m2 velocity u2 from x-axis. This I have supposed x-axis. From x-axis it makes an angle theta 2. Here they are colliding. After collision they will be separated. Actually like that they will separate here. Like that they will separate. But I have shown this from here because we can take components. We can see it easily. That's why I have taken here. Okay, this mass I have taken here. Only we have shown in figure. But actually they will separate from here. M1 has velocity v1, M2 has velocity v2, and angle made. Suppose v1 velocity make angle phi 1 and v2 velocity make an angle phi 2. What will be the equation? Since we know in elastic collision what happened, total momentum is conserved, also total kinetic is conserved. But here in two-dimensional figure, we will take along x-axis and also we will take along y-axis. This along y-axis. We are dividing total linear momentum along x-axis and along y-axis. We are dividing in two parts. So see, what we know, if any vector, suppose momentum p is here, if you are dividing, this angle is theta. If you are dividing in component forms, so along theta component is what? P cos theta, and perpendicular this component is what? P sin theta. If you want a rectangular components of vector quantity, okay, along theta that component is what? P cos theta, and perpendicular to that component is what? P sin theta. So see here, this momentum is what? M1 U1, and this making angle M1 U1. This angle is theta 1, so this angle is theta 1. Actually, what are the two components of this angular momentum? You can see along theta 1 or along x-axis, its component is what? M1 U1 cos theta 1, and perpendicular component is what? Along this M1 U1 sin theta 1. So this is the component of initial momentum, momentum before collision of mass m1. So mass m1 has momentum m1 u1. You have taken component along x-axis, so that is in positive direction of x-axis m1 u1 cos theta 1, and perpendicular, actually this is negative y direction, m1 u1 sin theta 1. Same way, if we go for the components of m2 u2, momentum of second mass m2 has m2 u2. This m2 u2, if you want to break components along x-axis and along y-axis, this angle is theta 2, this angle is theta 2. So what happened? Along positive direction of y-axis, this is m2 u2 cos theta 2, and rectangular components upward, this is what? m2 u2 sin theta 2. So this I have taken components of m1 u1, momentum of first, and m2 u2, momentum of second. This is before collision. This is what? Before collision. before collision. After collision what happened? This I have shown here. Actually they will separate it from here. Only I have shown here. Velocity is v1, it makes an angle phi1, and velocity is v2, it makes angle phi2. So what are the components? If we take components m1 v1, m1 v1 has two components. Along x-axis m1 v1 cos phi1, and along y-axis component is m1 v1 sin phi1. Same way, the momentum after collision of mass m2, it has two components. Along x-axis, what will be the components? m2 v2 cos phi2, and perpendicular to this, and along y-axis m2 v2 sin phi2. This here I have breaked before collision, this is after collision. After collision. Okay. Before collision, what are the momentums, and after collision velocity v1 v2, and we have taken the component along x-axis and along y-axis. Along y-axis. So see here, by law of conservation of momentum, what they are saying? Take care. We have to take along x-axis, along y-axis separately, and also elastic collision is there. So law of conservation of energy we have to apply. So firstly I am applying law of conservation of momentum. So law of conservation of momentum. Firstly we are taking along x-axis. So see here, along axis is what happened? Initial momentum before collision, both particle m1 u1 cos theta 1, m2 u2 cos theta 1, and after collision m1 v1 cos phi 1, m2 v2 cos phi 2. All are along positive direction of x-axis. So before collision this momentum, after collision this momentum. So before collision what happened? Momentum is what? m1 u1 cos theta 1 plus m2 u2 cos theta 2. After collision what are the momentum? m1 v1 cos phi 1 and plus m2 v2 cos phi 2. So this is the first equation. First equation I have made. Along x-axis momentum before collision, momentum after collision. Along y-axis, what are the total momentum? Along y-axis, what are the total momentums? ठीक है. अब along y-axis अगर हम total momentum देखें तो m2 u2 sin theta 2, here क्या है बेटा? m1 u1 sin theta 1. Then you can see here m2 u2 sin theta 2, positive I, m1 c1 u1 sin theta 1, negative I, negative the theta 1 theta 2 with the sign conversation if you are taking, take it, what happen? Along y-axis what will be the momentum? This positive and this we have taken negative direction. So m2 u2 sin theta 2 minus m1 u1 sin theta 1 is equal to what? m1 v1 after collision sin phi 1 minus m2 v2 sin phi 2. So this will be the second equation. Along y-axis we will take the momentum. I have taken with sign conversion. So theta 1, theta 2 we will take only positive. Okay, so that's why we have taken with the sign conversion. What happened? m2 u2 sin theta 2 minus m1 u1 sin theta 1 is equal to m1 v1 sin phi 1 minus m2 v2 sin phi 2. So this is the second equation. Achha, third thing is what? In elastic collision kinetic energy is also conserved. kinetic energy is conserved. So kinetic energy is a scalar quantity. There is no need of direction. So only kinetic energy before collision, kinetic energy after collision. Kinetic energy before collision is what? Half m1 u1 square plus half m2 u2 square. This is before collision, and after collision kinetic energy will be half m1 v1 square plus half m2 v2 square. So this will be the third equation. So three questions we will form. Okay. First is what? m1 u1 cos theta 1, m2 u2 cos theta 2. Here m1 v1 cos phi 1, m2 v2 cos phi 2. Along y-axis m2 u2 sin theta 2 minus m1 u1 sin theta 1, m1 v1 sin phi 1 minus m2 v2 sin phi 2. And kinetic energy conserved m1 half m1 u1 square plus half m2 u2 square, half m1 v1 square plus half m2 v2 square. In some books you can see maybe here they have taken positive sign plus, but then they have to take theta 2 as from downward, they will take as negative. So then negative positive becomes positive. Negative and positive becomes negative. So I have taken with the direction, that's why you can take here negative sign. So this will be the three questions. After solving these three questions, we can find the final velocity after collision, elastic collision in 2 dimension. See, here we are talking about the inelastic collision in 2 dimension. अभी हम लोग जो बात करने जा रहे हैं बेटा inelastic collision in 2 dimension. See here, suppose 2 balls are there. This is one ball m1 velocity u1, another ball m2 velocity u2. When they are colliding, here suppose they have collide. Another ball, they have collide. Actually, in collision, what happened? They are transferring, they apply force, every action is equivalent, opposite reaction. So there is some line of action. Suppose this line of action is along this, along x-axis I have taken as line of action. Along the line of action, action reaction is there. Okay. After that, what happened? This m1 has velocity becomes v1 and this m2 has velocity becomes v2. Okay. This is the situation. m1 u1, here m2 u2, m1 this makes angle with the x-axis. Suppose this is theta 1, this is theta 2. After that, this angle is phi 1, this angle is phi 2. And what are the line of action for collision? This I have taken as along x-axis. Mean along y-axis they are not applying any force. Along, this is the line of action. I have taken along x-axis they are applying force, action and reaction, and after that they are moving with velocity v1. And this is velocity v2 at an angle phi 1 and at phi 2. This is inelastic collision. So there will be loss of kinetic energy during the collision. And C we have taken is the coefficient of restitution for this motion. So see here, if this I am representing, remember one thing, x-axis I have taken line of action. There along x-axis only action reaction is there, or they are applying force in collision, they are applying force to each other. So this thing we have to remember. So see, again I am going to represent it in a single line. This is the x-axis. Here m1 u1, ठीक है, here m2 u2. After collision I am showing here this has velocity m1 has velocity v1 at angle phi 1 and m2 has velocity, this has velocity m2 has velocity v2 at an angle phi 2. So see here, I have told earlier, suppose this is m1 u1, this angle is theta 1, this angle is theta 2. So what will be the forces along x-axis? What are forces are acting along x-axis? So we can see here the force along x-axis. The force along x-axis will be what? M1 U1 has two components, that is M1 U1 cos theta 1. Here same as previous, M2 U2 cos theta 2. Perpendicular axis M1 U1 sin theta 1. Here M2 U2 sin theta 2. Same as here M1 V1 along x-axis M1 V1 cos phi 1. Here M2 V2 cos phi 2. Same as previous. If we are taking the components along x-axis and y-axis, m2 v2 sin phi 2 and here m2 v2 sin phi 1. These we have taken in the forms of components. To see what we have seen, along x-axis total linear momentum is conserved, then they are applying force to each other. There are force of collision. Okay. So what happened? Along x-axis total linear momentum is conserved. Along line of action, by law of conservation of momentum, what happened? M1 U1 cos theta 1 plus M2 U2 cos theta 2 is equal to what? M1 V1 cos phi 1 plus M2 V2 cos phi 2. This will be the one equation. Along x-axis total linear momentum is conserved, but perpendicular to line of action, that is along y-axis, perpendicular to line of action, there is no force acting. So no force acting mean momentum of first ball before collision is equal to momentum of second ball after collision. The momentum of first ball is what? M1 U1 sin theta 1. The momentum after collision, that is what? M1 V1 sin phi 1. So what happened? Here if we'll see, the M1 U1 along y-axis are along perpendicular to line of action. Momentum of first ball before collision is equal to momentum of first ball after collision. So what happened? M1 U1 sin theta 1 is equal to what happened? M1 V1 sin phi 1. Here M1 V1 cos phi 1, M1 V1 sin phi 1. So before collision along y-axis momentum of first ball will same, M1 U1 sin theta 1 is equal to M1 V1 sin phi 1. Here also M1 we can cancel. Take U1 sin theta 1 is equal to V1 sin phi 1. Same way for second mass, before collision M2 U2 sin theta 2, after collision M2 V2 sin phi 2, both will be the same. So this is second. Third equation is what? M2 U2 sin theta 2 is equal to M2 V2 sin phi 2. M2 also we can cancel. U2 sin theta 2 is equal to V2 sin phi 2. This will be the third equation. And one is in the form of coefficient of restitution. What is coefficient of restitution? Coefficient of restitution is what? The ratio of relative velocity of separation to relative velocity of approaching by negative sign. So what happened? Relative velocity of any coefficient of restitution, relative velocity of separation minus sign with the relative velocity of separation. So relative velocity of separation along line of action, what happened? m2 v2 cos phi 2 minus m1 v1 cos phi 1 divided by relative velocity of approaching क्या होगा? m2 u2 cos theta 2 minus m1 u1 cos theta 1. ठीक है, इसको यहाँ मल्टीप्लाई कर दें तो वी कैन से m2 v2 cos phi 2 minus m1 v1 cos phi 1 is equal to e times coefficient of restitution times minus sign to this plus this minus m1 u1 cos theta 1 minus m2 u2 cos theta 2. This will be the equation 4. This is the fourth equation. So this 4 equation will form for inelastic collision. You can see here, by solving these 4 equations we can find final velocities. Along line of action, total linear momentum is conserved. Perpendicular to line of action, no force is acting. If individual momentum of m1 and m2 will conserve, u1 sin theta 1 is equal to v1 sin phi 2 and u1 sin theta phi 1 and u1 sin theta 2 is equal to v2 sin phi 2, and in terms of coefficient of restitution, relative velocity of separation m2 v2 cos phi 2 minus m1 v1 cos phi 1 e times m1 u1 cos theta 1 minus m2 u2 cos theta 2. So these are the 4 equations. By solving this we can find the velocity of inelastic collision in 2 dimensions.